Okay, this problem is related to hardness of water. So this says a sample of hard water contains 96 ppm of SO42 minus. So a sample of hard water contains 96 ppm of SO42 minus, 183 ppm of HCO3 minus, and Ca2 plus has only cation. This means anions are balanced by cation, that is Ca2 plus. So I will have in solution CaSO4, you can call. So solution contains CaSO4 and the solution contains CHCO3 whole twice. This is the only thing. So cation is Ca2 plus, anion is SO42 minus, and another anion is CO32 minus, HCO3 minus. So you have these are the anions and this is the cation that is present. Now the question asks, how many mole of CaO will be required to remove HCO3 minus from 1000 kg of this water? So what we are doing is, we are taking 1000 kg of this water, hard water, and we are asking how many mole of HCO3 minus or CaO. So let me read, how many mole of CaO, not HCO3 minus, how many mole of CaO that is required to remove HCO3 minus from the hard water. So what I have 1000 kg of hard water and I want to remove HCO3 minus, only HCO3 minus, find it. I want to remove HCO3 minus, and to remove this HCO3 minus, what we are doing is, so I have sample, this contains HCO3 minus, and to remove this HCO3 minus we are treating this sample with CaO, and this HCO3 is removed. So HCO3 minus gets removed. And now the question asks how many mole of CaO that is required to remove this HCO3 minus. How many mole of CaO that is required? That is my question. Now let us discuss before what is ppm. Already we have discussed in the class. Let us discuss again. What is ppm? So the full form of ppm is parts per million. So this means, and this is in this question, this is given, this part per million weight by weight, that is mass by mass. So weight by weight. Are you getting or not? So if I take per million, that is 10 to the power 6. If I take 10 to the power 6, I will have one part. So one part in 10 to the power 6 part. So what is this meaning of part per million is, one part of anything you can have in 10 to the power 6 part. Are you getting? So if you have 10 to the power 6 something, 10 to the power 6 gram, then you will have that particle as 1 gram. So I can say 1 gram, because this is weight by weight, in 10 to the power 6 gram. Are you getting or not? So this is the meaning of part per million, weight by weight. Now question is easy. Let us first calculate what is the weight of HCO3 minus. So weight of HCO3 minus in 1000 gram or 1000 kg. So what is the 1000 kg of water? So HCO3 minus we have, that is 183 ppm. So this means I will have, if I take 10 to the power 6 gram of water, you are getting on ppm means 10 to the power 6 part, and then in that case I will have 183 part of 10 to the power 6 gram of water will contain 183 gram, because part by part, 183 gram of HCO3 minus. Are you getting? And 10 to the power 6 gram is nothing but 10 to the power 3 kg. Are you getting? So 10 to the power 3 kg will contain 183 gram of HCO3 minus. And this is the same thing. We have to we want. So my sample is 10 to the power 3 kg, 1000 gram, 1000 kg. So this means in 1000 kg water. So my sample is 1000 kg. I will have HCO3 minus, that is 183 gram. Are you getting or not? We can calculate mole of HCO3 minus. So let us say mole of So you calculate yourself mole of HCO3 minus, and this will be molecular weight of this is 61. You can calculate yourself 183 by 61. So this comes out to be 3. So I will have 3 mole of HCO3 minus. Now the question is, HCO3 minus reacts with CaO, and I can write, and then HCO3 minus gets removed. So we have to write a reaction, and that is the most important part we have here. CaO reacts with HCO3 minus. In solution, HCO3 minus exists in the form of CaHCO3 whole twice. So in writing the balanced equation, I will use that species, that is CaHCO3 minus, and that is whole twice. And this will form, so now this is a base. So this is an acid base reaction. So this is a base, and this is acid. HCO3 minus will act as an acid. So this is an acid base reaction. It will form salt CaCO3 plus water H2O. Now let us balance this equation yourself. I think if you multiply this by 2, you will get the balanced equation. What will happen? Because you have 2 CaO, O2 minus, it will take 2 plus, 2H plus, 1H plus from HCO3 minus, another H plus from HCO3 minus. So we will have CO3 2 minus, and that CO3 2 minus will combine with Ca2 plus, and this will form CaCO3. Are you getting or not? And you have 2 CO3 minus, one CO3 will combine with this, and one CO3 will combine with this Ca2 plus, and then you will have CaCO3. You can see the balanced equation. This is salt, and this is water. This is nothing but acid base reaction, and this reaction you have to remember. If it does not able to write this equation, no, you cannot solve this problem. Now mole of HCO3 minus is 3. So you see, what is the mole of CaHCO3? Because 1 mole of CaHCO3 contains 2 mole of HCO3 minus. So this means mole of HCO3 minus is 3, then mole of CaHCO3 is 3 by 2. Are you getting or not? Because 1 mole of this will contain 2 mole of HCO3 minus, and HCO3 minus is 3 mole, so CaHCO3 will be half of this, so that is 3 by 2. I think you are able to understand. You see here, I can show you. So CaHCO3 whole twice, this will give you Ca2 plus 2 mole of HCO3 minus. Are you getting or not? So this means if I have 1 mole of HCO3 minus, I am getting 2 mole of HCO3 minus. CaHCO3 I have 1 mole, then I will have CaHCO3 minus 2 mole. So this means HCO3 minus is half of the CaHCO3 is half of the HCO3 minus. You getting? So that's the same thing I am doing here. So what is the mole of base that is required? Of course 1 mole reacts with 1 mole, so base also required is 3 by 2 mole. Are you getting? So now I can say mole of CaO required, and this will be 3 by 2 mole. Are you getting? So this is the mole of CaO that is required in this case. Now we also have the next part. This says if 1000 kg of this water is treated with calculated amount of CaO, so this means I have 1000 kg of water, hard water of course, and this water is treated with 1.5 mole of CaO. So what will happen? So I have two kind of hardness, sulfate hardness and bicarbonate hardness, and you have Ca2 plus. So what had happened? You have formed, so after this what you have? You will have SO4 minus, and HCO3 is gone. And HCO3 is gone, but you have formed CaCO3. Are you getting or not? How many mole of CaCO3 is formed? 3 by 2 into 2. So 2 mole of CaCO3 is formed. Because you see here, 1 mole reactant gives 2 mole, so 2 mole of CaCO3 is formed. So after this reaction you have CaCO3, that is 2 mole that is formed, and SO4 minus that will remain same. Initially it was 96 ppm, so it will again remain as a 96 ppm. If I know ppm, we can always convert into weight. And now Ca2 plus was initially there, so Ca2 plus will be there. Are you getting on? Because originally cation Ca2 plus has not removed. Now the question says, if the 1000 kg of water treated above as calculated with calculated CaO, what will be the concentration of residual Ca2 plus ion in ppm? So now we have to find what is the concentration of Ca2 plus in ppm. So residual Ca2 plus. Now you see, this CaCO3 is basically solid, so this will get deposited, it's get precipitated. Now we have to find what is the Ca2 plus that is remaining in the solution. So now you see, we have two kind of Ca2 plus. One Ca2 plus that is attached to CH plus, and one Ca2 plus that is attached with CaSO4, that is SO4 2 minus. So I will having Ca2 plus corresponding to SO4 2 minus. So if I know the mole of SO4 2 minus, I know the mole of Ca2 plus, because mole of CaSO4 is same as mole of SO4 2 minus is same as mole of Ca2 plus. So let us first find mole of SO4 2 minus in 1000 kg of water. So you see, we have already calculated. So how we calculate weight? So if you have 10 to the power 3 kg of water, you have 183 ppm of HCl. So this means in 10 to the power 3 kg, I will having 183 gram of HCl3 minus. Similarly, if I do the same calculation, now I can say weight of SO4 2 minus, that will be 96 gram. Only thing is, in place of 183, now I have to replace with 96, because SO4 2 minus is 96 ppm. So what is the mole of SO4 2 minus? So this will be 96, and this divided by molecular weight is 32 plus 64, 96. So you will have 1 mole. Are you getting or not? So you see, residual mole of Ca2 plus. So we have to find residual mole of Ca2 plus in ppm. So Ca2 plus will be 1 mole, because the mole of SO4 2 minus is mole of Ca2 plus. So mole of Ca2 plus, that is again 1 mole. And this is same as, so weight of Ca2 plus, now I can find weight. So weight of Ca2 plus, this will be equal to this into molecular weight. Molecular weight of Ca2 plus is 40. So 1 into 40, that is 40 gram we will have. So what is the ppm? You see, if we have 40 gram in 10 to the powers, so what is the water? Water is 10 to the power 6 gram. The 10 to the power 3 kg is same as 10 to the power 6 gram. Are you getting or not? So 10 to the power 6 gram contains 40 gram. So what is the ppm value? ppm is 10 to the power 6 is a million. So 1 million contains 40 parts. So 40 ppm. Are you getting or not? So ppm of Ca2 plus, that is 40 ppm. The next part of the question says, if the Ca2 plus ion in 1 liter of the treated water is completely exchanged by hydrogen ion. So now they are saying something about 1 liter of solution. So let us say 1 liter of water, if I take treated water, that is, it is treated with CaO. So this water is treated with CaO. Already it is treated. So I am taking a treated water of 1 liter treated water. So now it will only contain Ca2 plus. Of course, it will also contain SO4 2 minus. Now question says, if it is exchanged by Ca2 plus ion, so there will be some Ca2 plus ion, and this Ca2 plus ion is exchanged by hydrogen ion. So it is exchanged by H plus ion. Are you getting? So this is exchanged by H plus ion. What will be the pH? So what is the pH of solution? So first find out the mole of Ca2 plus in 1 liter solution. So you have 40 ppm, that is 40 parts per liter, per 10 to the power 6 kg. Now you see, we have already calculated mole of Ca2 plus in 1000 kg. So you see, mole of Ca2 plus, here we have mole of Ca2 plus in 1000 kg is 1 mole. Are you getting? And 1 liter is nothing but around 1 kg. So if density is 1, I can assume 1 liter is 1 kg. Are you getting? So now I know 1000 kg contains 1 mole. So 1000 kg of water contains 1 mole of Ca2 plus. Are you getting? So let me do something like this. So this contains 1 mole of Ca2 plus. So now I have only 1 liter of solution. So 1 liter is around 1 kg. So 1 kg will contain 10 to the power minus 3 mole of Ca2 plus. And now this Ca2 plus is extended by H plus. So if you remove Ca2 plus, so you have a solution, and this contains Ca2 plus. And what you are doing is you are removing Ca2 plus and you are putting H plus. And to maintain the electrical neutrality, 1 mole of Ca2 plus is exchanged by 2 mole of H plus, because Ca2 plus contains 2 plus charge. Then I have to put 2H plus. So H plus added H plus will be 2 times mole of Ca2 plus. Are you getting? And the mole of Ca2 plus is 10 to the power minus 3. So this is 2 into 10 to the power minus 3 mole. So 1 liter contains this. So what is the pH? So pH is, so this is the mole of H plus, this is the 1 liter. So this is same as mole per liter. So concentration is same as, so H plus concentration is 2 into 10 to the power minus 3. So what is the pH? Minus log of 2 into 10 to the power minus 3. If you solve this one, so this comes out 2.7. Okay, let us discuss the next problem.